Here will be a rundown of some examples from the homework on dividing polynomials using long division and or synthetic division of a polynomial. So we have this polynomial, k to the third power plus 8k squared plus 10k plus 21, and we're going to divide that by k plus 7. Now, if we would be able to factor the big polynomial into something that would have a k plus 7, we could cross cancel and simplify the fraction that way by putting this k plus 7 underneath. And then if this would factor, in this case it would not. It would factor by grouping, so this would have a common factor of k squared. This one here, the 10k and 21, would have no common factors. So then what would be left over after you take out k squared would be k plus 8, and then 10k plus 21. Those are not equal, therefore factoring by grouping is not going to work. So we look to another method to divide polynomials. All right, since we're going through the process of kind of the backwards method of multiplication here. So in our polynomial with the divisor of k plus 7 and the dividend here of k to the third, 8k squared, 10k, and 21, we have to divide, just like we would have divided long division with a 5-digit number, say, divided by a 2-digit number when we first learned long division. So we want this k to the third, we want to cancel that out. So we need something up here that will multiply to give us k to the third. So in this case, that's going to be k to the second. And I'm going to write that underneath in the kind of the column of where the k to the seconds are. If there were ever a gap in here, so k to the third, k to the second, k, and no k, let's say this was just k to the third and then we skipped to 10k, we would have to implement an automatic 0 k squared. So you always have to have each degree filled in. So now we can multiply. K squared times k gives us k to the third. K squared times 7 is going to give us 7k squared. Let's make that a better 3. So now what we're going to do is we're going to subtract. So when you subtract polynomials, what we're going to do is we're actually going to subtract each one of these. You just make them the opposite so that these k to the thirds cross out. We have 8k squared minus 7k squared gives us k squared, which is just 1. The next step would be to bring down 10k, and now we start the process over again. So now we need this k squared to cancel out, so we need something that we can multiply to k to give us k squared. So in that case, it is a 1k. So k times k gives us k to the second. K times 7 gives us 7k. Again, we're subtracting, so you change the sign of each of the polynomials there. The k squareds cross out again. 10 minus 7k gives you 3k. We now have to bring down this 21. So 21 comes down. We now need the k times the value here needs to be 3k. So we're going to put a 3 plus 3. So 3 times k gives you 3k. 3 times 7 gives you 21. Change the sign of each. Subtract. 3k's cross out. 21's cross out. So there is actually no remainder. So there's the answer when we divide. Now you can always check by using your FOIL multiplication, your box multiplication method, by taking the divisor times the quotient, and it should equal this dividend down here. So if we multiply k plus 7 times k squared plus k plus 3, it's going to make this long k to the third plus 8k squared, so on and so forth. So you can always check. Right? If there happened to be a value left over at the end, then what we would do is we would just write right here, we would just put a plus, and then whatever this remaining value was, let's say for example this was a 20. So then 21 minus 20 would give you a 1. You would just say 1 divided by k plus 7. Okay? So that could happen from time to time. It doesn't necessarily always happen, but it is a possibility. So as we move along doing another example, moving down to number 7 here, we start the same way. The dividend goes here. Underneath the division sign, the divisor is what would be underneath. Again, we could try to factor it. It may work. In this case, again, it's not going to. But if you could divide it so that you created a fraction with that 6v minus 5, if you happen to have a 6v minus 5, you could cross-cancel it. If it doesn't, or if you skip that step and don't want to factor it and divide it just this other way, same thing. So we want this 6v multiplied by something to equal a 12v to the third. So in that case, since we need a 6 times some value to give us a 12, we need a 2v to the second. So when we multiply, 2v to the second times 6v is equal to 12v to the third. 2 times 6 is going to give you 12v. Oh, I'm sorry, I got ahead of myself. So 2 times negative 5 is going to give you negative 10v to the second. Right. So now when we're going to, again, change our signs, so the 12 becomes a negative, this 10 is actually going to become a positive because we changed the sign since it's the definition of subtraction. The 12s cross out. We now, in this case, add because they're both positive. So we have 48v to the second. We're going to bring down our 16 and the minus sign. So we need a 48. So 6v times some value to equal 48 is going to be an 8v. 8 times 6 is 48v to the second. 8 times negative 5 is negative 40v. Again, we're going to change our signs. 48's cross out. We're going to combine these two by taking positive 40 and the negative 16, and that's going to give us a 24v. Bring down our 20 and the negative sign. So now we need something times 6v that's going to equal 24, and in this case that's going to be a positive 4. 4 times 6 is 24v. 4 times negative 5 is negative 20. We again change our signs. 24's cross out, as well as the 20's cross out. So the final answer here is 2v squared plus 8v plus 4. So again, that would be the answer to the division problem. So all of this is the long division process of kind of creating this division. Doesn't want to zoom out here. All right, so that's the first part of the assignment. All right, moving to the back, down on to number 12 here is our example. We're going to go through the process of synthetic substitution. Synthetic substitution may be your preference as far as dividing a polynomial out. Again, if there is ever a gap in the degrees, you need to fill it in with a 0. So here is degree 4, 3, 2, 1, 0. If degree 4, and let's say for intents purposes that this is not there, we would need to imagine that that is a 0 x to the third. Again, that is not the case, but if there ever is a gap, you must fill that in with the 0. Okay? Now, what's nice about synthetic substitution is everything is based on only the coefficients. So what we're going to do is we're going to write these coefficients, -6, +53, -41, +6, and +16. And then over here, usually put a little box just to solidify yourself. What you have to do is take your divisor, but you have to set that equal to 0. So we're going to take x minus 8 and we're going to set it equal to 0. So that means that x equals a +8. That's what goes over here in the box. So now the process of synthetic division, or some people will call it synthetic substitution because it's the same process. This one, it just creates an end result as a quotient. You always bring the first value straight down. And then what's going to happen is you're going to take this value and multiply it to the box. So in our case, we bring down -6, we multiply it to 8, and what that's going to do is that's going to give us a -48, and you put it underneath the next column. We add, or in this case, it's going to be a subtraction straight down. 53 plus -48, or 53 minus 48, is a +5. You then take 5, and you're going to multiply it to 8, and then that answer goes here. So this would be a 40. -41 plus 40, because that's positive, that's -1. Now multiply -1 to the box, or -1 times 8 is going to give you -8. Put that underneath the next column. We add 6 plus -8, or 6 minus 8, is -2. -2 times 8, -16. We're going to add, and that's going to be 0. So in the end, what this is, it's all based on the column. So you start all the way here at the right. This is your remainder. This is your constant. This is the degree 1. This is degree 2, degree 3, so on and so forth. So if we had a degree 4, a degree 5, a degree 6, if there were values there, that would fill in. So the end answer here in this problem, when we divide, is going to be a -6x to the third power, a +5x to the second power, a minus x, or 1x, minus 2. And again, we have no remainder, so we don't have to worry about that. So again, much cleaner. I believe that it's much quicker than doing the long division. It saves you a little bit of headache of creating the big long division process. Okay, moving to another example, and then the rest will be your assignment here. Just went to number 15 just because, again, the synthetic division coefficients, the one involves a negative. So what, again, we're going to do is we're going to write our values. So you take the coefficients here of your dividend. This is what would go underneath the long division bar. And we're going to write our coefficients. N to the third is a 1. And then we have a 15, n to the second, 47, and a -38. And then again, you have your box. We take this value right here, but we're setting it equal to 0, so it becomes the opposite. All right, the +6 is going to become a -6 over here. And then now we start that process. This one comes straight down. That's a 1 times -6 is -6. We add, we're going to get 9. Multiply is -54. Add is -7. Multiply is 42. And our answer at the end is a 4. So in this case, our remainder is 4. And then this is the constant. This is x, and this is x squared. So the final end result to this product, or I'm sorry, this quotient, is 1x squared, or you can again just write x squared, plus 9x minus 7, and then what you'll do is you'll say plus the remainder, but we're going to say 4 over x plus 6. I wrote x's, I guess they're n's. Okay. But this remainder, notice how I take the remainder and I plug it as the numerator of what you're dividing by. Okay. Now again, the same result would happen if we would have done long division. So if we would have done the long division, this would have been n to the third, 15n to the second, 47n minus 38. If we would have plugged in our n plus 6 over here, first thing you need to do is multiply to get n to the third. So that would have been 6n squared. Those cancel out. We would add, we would wind up with 21n squared. And something is off here. Oh, I caught my mistake here. Forgot to change the signs. Make them negative, negative. So again, this is one of my pet peeves of long division here. So now we wind up back to where I was going too fast here. All right, so 15 minus 6n squared gives you 9. Bring down your 47. So now we need a value multiplied to n to get you 9. So we need to make 9n. So now 9n times n gives you 9n squared. 9 times 6, 54n. Change the signs. Don't forget that this time. All right, those will cancel out. So 47 and the minus 54 is going to give you a negative 7n. Bring down the negative 38. The last step of this is to get the 7n to cross out. So to do that, we need to have a negative 7. That's going to give me negative 7n. And then a negative 42. We change the signs again. And we're left with 4. So then our remainder becomes 4 over what you're dividing by. Same result. Much longer, much more confusing if you forget to flip the sign like I did. But again, I don't have a preference. I want you to be able to divide these polynomials. It's the last little phase of the polynomials section that we're dealing with. Kind of a more of a college algebra process here with the synthetic division or synthetic substitution, whatever you want to describe it as. All right, so I hope that this helps. You get through the remaining part of this assignment using long division, using synthetic. I would like you to try at least one of each. So if you have a preference, if you like the synthetic substitution much better, by all means you can use it on the whole assignment. But I do want you to at least try a long division problem so that you at least see how it works and how it's useful.